Okay, so what I'm trying to do now. Okay, just a bit of a background. I use Suzuki vehicles, and then I use Suzuki Access. It's a really good vehicle, and it has this digital board which has a Bluetooth connection, so I can connect it to my phone, and I can use it to receive notifications and use it for navigation and all that shit. It's really nice, but I really hate the way the app does its navigation. For example, I can't search for my own places, and when I search for it, it gives me like random locations like 1000 or 2000 kilometers away, and I cannot enter like specific coordinates where I want to go. And it's not using Google Maps, it's using its own navigation engine, which means I can only do a select number of locations. So if I want to go somewhere new, I either have to put Google Maps and put earphones and to hear the route, or I have to use this but put to the nearest location from where I know I have to again use Google Maps, which is pretty annoying. So I was like, I am a software engineer, aspiring software engineer, why don't I do it myself? So this is what I've done. I have currently connected my phone to Bluetooth, and I've gone on a ride, and I've connected my phone to my laptop. As you can see here, I've taken the log of Bluetooth, and this is the log of the Bluetooth. This is the entire log of what and how we went. This is the Bluetooth command, and we have each frame. I am trying to reverse engineer this so that I can build my own app that I can connect to my own scooty, and you can use my own maps. It's gonna be easy. This is my phone connecting to Texas Instruments, which made the IoT automotive whatever device, and it sends a lot of packets, 27,000 packets. So yeah, it sends like 28,000 packets, and then this starts sending me a bunch of shit back to me. Each packet is like this long. It's very short actually. It just has like 1 or 2 bits of information. Okay, update. It's been a while, and what I have figured out is if I go to Wireshark here, and this is the ping that my scooty gives, and this is my phone. Like it says here, it's nothing phone 2A, which is my phone right now. That doesn't really matter now, and we have a lot of other packets. But let's just take a random packet here, and if I go here, and look here, it actually uses a public key open credential. So that is a protocol used by a lot of automotive stuffs, like automotive vehicles in China. It's pretty well documented, but the thing is, it means it's encrypted, which means it's either encrypted client side on the app or server side, which I doubt it's happening. So I have two options now. One is to put the Suzuki APK here and then try to see what's inside, which seems like a headache to me, and now that's why I'm going to do option number 2, which is build a wrapper app. So the connection happens to the main Suzuki app, but then we take over the connection in a different app, and then this app, what it does is it reads the Google Maps notification, and then it sends packets to my scooty disguised as the actual app so that I get the route information. So that's what I've actually done here. So there are 3 clients. One is the scooter client, and one is the Google Maps activity parser. So what this does is it reads the notification from my whatever route I have, and then immediately parses it. Like this is based on the notification that the Google gives. So when I'm using the scooter in direction mode, there are a lot of emojis or like pixelated images that come when I'm driving. It says right arrow, straight arrow, and then there's cross, all that stuff. So I don't know which side corresponds to which one. So I just have to calibrate it right now, which is what I'm going to do, and see how it works. I'm actually near my scooter right now. So once I put my key, you'll be able to see how it works. And it actually connected to my phone automatically because I had the app open. So what we want is to check if this is connected. I've already tried this once, but let's just connect here, and we need the log to say that it's connected. So it actually found the right characteristics, so it is connected to my scooter right now. And if I put this, it'll actually show one of the emojis. So I can try the other ones. So this is to turn right, this is to turn left, this is for a destination, and this is to join right on a main road, I guess, is the other one. And this is to tilt right, go left on a split cross. This is the other one. And we have full straight. So we have matched all the packets with each other, and we can actually edit. Let's say I am 60 meters away and ETA is like 0845. I'm gonna need remaining meters 500 meters, and if I give that, it is automatically updating here. So it says I'm gonna reach at 8:45 p.m. 500 meters away in 60 meters. see it works. Let's increase this to like 800 and see if it works. Send that, and you see this has also increased as I'm nearing wherever I'm reaching. So this has to decrease and then show me the next move. So this wrapper app works. I just have to make it such that it reads the actual maps data and shows it in my scooty. Also, this is my app that I built to block reels and YouTube shorts. So if you want to check it out, you can also check it out. I know the camera is bad, but yeah. So another problem was I had only 8 maneuvering emojis. I'm just gonna call them emojis for this video. Just deal with it. 8 maneuvering emojis. But then in the test ride which I went with the Bluetooth logging on, I did not come across any roundabouts or had to take any sharp turns or sharp almost U-turns or U-turns or anything. So those emojis are missing. And one way to do them is to try every single bit and see which emoji is for a U-turn and for a roundabout and all that shit. So what I'm going to do now, I'm not going to show it in camera because it's a lot of work, but what I'm going to do now is going to map every single bit, which is like 256 bits, which is already a lot. So I'm going to have to map every single bit to its corresponding emoji or emote or like icon which it shows. Most of these bits are going to be empty bits. They're not going to show anything, but some of these bits need to have to show some emoji. Some are missing, so I'm gonna have to fix all of them. I'm gonna try to get all of the emojis. Okay, so I did a drive test while coming here using my app, and it sort of worked, but then it was not too accurate. There were some mistakes, like it would say a bit too late after I turned, and sometimes it would give the wrong direction. But for the most part it works. I am able to bypass the actual app and then connect it to my app and then give the symbols like I have received come to the destination. Here is that what it's saying. So yeah, it works 90% of the time. It'll work. So I'm pretty happy with the result. I'm pretty sure there are a lot of symbols I still have to configure and calibrate and a lot of emojis that I have to maneuver, but then I'm just realizing that I have my cybersecurity exam tomorrow. It's my final exam, so yeah, I don't think I should be wasting my time on this. So yeah, so there are two problems. One is the phone has to stay always on because the notification that Google Maps gives is a live notification. They don't give a push notification, and obviously it makes sense. They don't want to give push notification for every single meter that you move. So I have to keep the phone on so that the Connect to Bridge app has to always scan for the notification every like milliseconds or 100 milliseconds to see if there's any change in direction and then relay it to my scooty. And two, it is not always accurate. I don't know if it is because I haven't configured all the symbols to its respective bit, or if the Google Maps is a bit late, and or if my app is not working properly. I just have to figure that out why it's not accurate, because sometimes the app the maps say that I have to turn right in the voice, but then it doesn't show up properly when I drive my scooty. So I just have to figure that out. And there is always one more solution if I don't want to keep my phone on, is that I use accessibility service to open maps and dim the screen so that the screen stays off while the app keeps maps open in the background. We are all working. This is all like wrappers around existing apps because I can't really handle the internal tools. I don't have access to internal tools of Suzuki, or I don't have access to Gemini Maps API because that's paid. So I'm trying to work with like what I can do for free here, and this is what I have come up with. And honestly, it seems a bit too much work just for navigation. I would rather just stop at signals and look at route, or I would buy a tripod that probably costs like 500 or 600, pick it up on my scooty. Either ways, I don't drive to new places like a lot, so I don't think it will affect me. It's just a minor inconvenience that I tried to make a solution of, and honestly it kind of worked, but I'm not going to work on it at least for this for the next few months, because I have my exams coming up, and this is like actually a bit too much work, even though it's very interesting. But I will put the GitHub repository public, so anyone can fork it and anyone can play around with it and see if it works. If you own a Suzuki scooty and if you've been having the same problem as me, you can try it out and let me know how it goes. That's just a fun little project I had the day before my biggest exam, and yeah, it's just what you do before exams, guys. You don't study, you do all this shit and you fail.